Hello, let's look at section 2.7, which is non-differentiable functions. So this section is really short. If a function is not differentiable, so differentiable means that the derivative exists. So if a function is not differentiable, that means the derivative does not exist. Okay? So if a function is not differentiable, which means derivative does not exist, it means we cannot take the derivative, or the derivative is undefined. So let's look at the absolute value function. The absolute value function is not differentiable at x equals 0. So let's see what it looks like. So this is the absolute value function. It looks like a v, right? When my x values are positive, the y values are positive. If the x values are negative, the y values are still positive. Okay. So the slope to the right of 0 is positive 1. So this is like the graph. This is like y equals x, right? And the slope to the left of 0 is y equals negative 1. So this is like negative x. So the slope here, m equals 1. The slope here, m equals negative 1. And as we get closer and closer to 0, it depends on whether you're going from the right or the left. From the right, the slope will always be 1. From the left, the slope will always be negative 1. So we're never actually getting to a close point. Like the two slopes are never going to match. They're never going to actually hit a common value. So that's why we say that the derivative does not exist, or it's not differentiable at x equals 0. Any graph that has a corner point is not differentiable at that corner point. Okay? Let's look at some other situations of non-differentiability, or where the derivative does not exist. So this is on page 166 in your book. So we looked at corner points. Okay, the two different slopes conflict. Anywhere you have a vertical tangent. Now remember, the derivative is the slope of the tangent line. A vertical tangent line or vertical line has an undefined slope. So therefore, if your graph has a vertical tangent, the slope does not exist, therefore the derivative does not exist. And anywhere you have a jump or a discontinuity, okay, like right here at the point C, there's a discontinuity, so the derivative does not exist at a discontinuity. Okay, again, this is on page 166 in your book. So if a function satisfies any of the following conditions, so at C, if there's a corner point, or at C if there's a vertical tangent, or at the point x equals C there's a discontinuity, then the function will not be differentiable. The derivative will not exist at C. Okay? So let's talk about differentiability and continuity. So this arrow is saying implies, or if, or you can also think of it if differentiable then continuous. So if a function is differentiable, that means it is continuous, okay? But if a function is continuous, it does not necessarily mean that it's differentiable. So can you give me a counterexample, or an example of where a function is continuous but it's not differentiable? So again, where is a function continuous but it's not differentiable? Well, how about let's look at one of these 3 points. A corner point. At a corner point, is the function continuous? Yes. It's continuous, but it's not differentiable. Okay. How about a vertical tangent? Is it continuous? Yes. Is it differentiable? No. Remember, continuous just means you can follow the graph using your pencil without lifting the pen from the paper. And then excuse me, discontinuous. Well, it's not it's not continuous if it's discontinuous, okay? So these are two examples of where you have continuous but non-differentiability, okay? And if a function is differentiable, then it has to be continuous, okay? So that's the way that works. So this only goes in one direction, not both directions. So if it's differentiable, then it's continuous, But just because it's continuous does not mean that it's differentiable, and examples of that are corner points and vertical tangents. Okay? So that is all of Chapter 2. If you have any questions, and that's the end of Section 2.7, which is the end of Chapter 2. If you have any questions, please get in touch with me. Thank you.